4W Consulting, representing the University of Southern California. I'm Wendy Wong, alongside Madeline Tran, Joseph Weissig, and Yusan Wong. And this is our presentation, New Technology for New Times. So first, a little bit of background. Outside of Banjul, Gambia, there is the Bakote dump site. It's a site of hazardous waste, open burning, and questionable labor practices. We were tasked with a plan in order to close the existing site and open a new site. So first, a deeper look into some of what our objectives were. For the closure of the old site, we were really seeking to reduce the environmental impacts and improve the living conditions of nearby residents. So that includes reducing emissions, reducing odor, reducing health risks, improving site stability, mitigating groundwater pollution, and monitoring other environmental impacts. For the opening of the new site, we were really trying to develop an entirely new system of waste management, one that's integrated in the community, creates profit and valuable resources, and really is an investment in waste management that will survive generations to come. In terms of some of the societal impacts that we want to implement, we really want to improve quality of life for everyone in the area. And that includes ending discrimination of waste pickers and other people who work with hazardous waste, creating well-paying jobs, and ending child labor. The current site is across the street from an orphanage, and that's actually been a source of child labor in the past, and we want to end this practice. And with that, I'll turn it over to Maddie.
First, we'll be going over the closure of the old site in Bakote. This section will discuss the implementation of the gas collection system, the cover, a groundwater pollution mitigation system, watering processes, as well as the redevelopment of the old site, and an overall financial analysis. So, a gas collection system is required for closure because of the decomposition of organic waste in landfills produces significant amounts of methane and carbon dioxide. This is undesirable because it can cause instability of the site and potential collapse. Additionally, methane is highly flammable, so it can cause uncontrolled fires. The emissions of these gases from the site is harmful to our environment, and gas migration to the communities is also harmful. Thus, a gas collection system is necessary for closure. Switching from an anaerobic without oxygen to a semi-aerobic with oxygen decomposition process can reduce emissions by up to 40%. This is done by installing gas extraction wells in the landfill to introduce oxygen into the waste and allow for the gas to escape up through the wells in a controlled manner. So first, a hole will be drilled into the waste layers with a well drilling rig. Then a perforated pipe will be inserted into the borehole. The area surrounding the pipe will be filled in with gravel, which will prevent anything from entering the pipe, so it's just the gas that will be extracted. Above the perforated section, a layer of backfill will be added, as well as a layer of bentonite in order to prevent air intrusion and gas escaping outside of the pipe. Finally, a landfill cover will be installed, which will be further detailed in the next section. A preliminary study to measure the amount of gas should also be conducted in order to determine the effective radius and how many wells need to be installed. Then, after gas is collected by the extraction wells, it will be combusted using a utility flare design. This is the simplest and least expensive combustion technology while still achieving a 98 to 99% combustion efficiency. Another option that was under consideration was converting the landfill gas into renewable energy. However, that would require an extensive installation of horizontal pipes both beneath and above the waste, as well as building facilities to convert the gas into energy. Thus, the treatment of landfill gas is not physically or economically feasible for the Bakote dump site. Next, I will be going over our proposed landfill cover. We propose a evapotranspiration cover for the Bakote dump site. It consists of 3 layers above the waste layer, an interim cover, coarse grain layer, and a fine grain layer. First, landfill compactors will be used to compact the waste prior to the installation of the cover. Then the interim cover will be immediately above the waste and composed of compacted clay. This will prevent any surface water from entering the waste and generating more leachate. Gravel or sand can be used for the coarse grain layer and will help reduce water percolation in the interim cover. And the fine grain layer will use available soil and it will retain any water until it's removed by evaporation or transportation through the vegetation. Tractors will be used to compact the waste and load the soil into the layers. A landfill cover is required because it prevents surface water from entering the waste and reduces leachate generation. It also prevents landfill gas from escaping from the landfill and forces the gas to vent through the extraction wells. It also reduces odor and insects. Pollution from leachate generated within the landfill can seep into the groundwater and affect human health. A proper landfill would typically have a liner and leachate collection system in order to solve this issue. However, since the Bacote dump site is already full of waste, there would be many challenges in order to install a liner and leachate collection system. It would be very labor-intensive and expensive and is not feasible for the site. A more suitable way for the Bacote dump site to minimize groundwater pollution is to divert surface runoff. So we propose a cover with a slope of 2 to 3%, which will ensure adequate diversion of surface water. Ditches on top of the cover should be constructed to guide the water into a water retention pond. These methods are much simpler and less expensive than an entire leachate collection system, while still producing good results for mitigating groundwater pollution. It will prevent erosion of the cover soil, which could have led to instability, and it will also prevent water from infiltrating the waste and generating more leachate. The landfill should also have groundwater and gas monitoring wells to observe the effects the landfill may have on the community after closure. The groundwater wells should be located both upstream and downstream of the landfill and should be checked at least every 3 months to account for variability in the seasons. Ambient air monitoring should also be implemented upwind and downwind of the landfill to understand the impact of emissions on the surrounding community. Samples should be collected and averaged at various times during the day to account for differences in wind. These monitoring procedures will evaluate the state of the landfill and determine if any additional measurements are needed to ensure the safety of the community. The monitoring will also allow the closed landfill to be redeveloped into something such as a community park. As long as these conditions are well within safe for humans, the site can be redeveloped to the wishes of the community. The community could work together on their own vision of what this new recreational land could look like. The closure of the Bacote dump site will require funding that can be supported by the government, international organizations, and waste management fees. The Canifing Municipal Council already has a variety of active vehicles in their possession that can be used towards closure, and the total cost of materials and equipment required for closure is projected to be around $3,658,000.
Okay, now let's talk about the opening of the new site. To design a new site, we need to predict how much waste we need to treat in the coming years. Using the waste growth data from the early 2000s, we formed a mathematical model to predict the waste output over the coming years. By 2030, we predict approximately 1,600 tons per day. With that said, we outlined a few requirements for the new site. First, we needed a design to handle the projected waste in the coming years. Second, we needed to design a way to efficiently transport the waste from the communities to the new site. And also, we needed to evaluate and consider different options to minimize costs and to maximize streams of revenue. And finally, we wanted to increase employment opportunities within the surrounding community. With 14 acres, our space is limited. But our main goal is to eliminate the harmful effects of a traditional landfill and to save the lives of the surrounding community. The design of our proposed site has 3 main stages. The first stage collects, contains, and sorts the waste, while the second and third stages treat and transform the waste. We will now look at these more deeply. In the first stage, the waste will be dumped into a temporary landfill. This landfill will be constructed of interlocking cells with liners to prevent toxic runoff. This will also have a leachate collection and processing facility and a gas collection system to collect harmful emissions such as methane and prevent them from going into the surrounding environment. After the waste has been sorted for recyclables and valuable goods, the waste will then be transported to a grinder facility to grind the waste into smaller grounds for further processing.
So stage 2 would be transforming the waste into a thermoplastic composite material to manufacture products like bricks and construction material according to the needs of the community. So this whole process is from a patent by UBQ Materials, who patented this process. So the first step is loading degraded heterogeneous waste into our heating facility. So the heterogeneous waste is required to be 10%, at least 10%, and a maximum of 60% plastic, and others will be non-plastic. And this is crucial to the second step of heating, because not only will the heating melt a proportion of the plastic components, which will help integrate the whole heterogeneous waste together as it acts as a binding agent, it also reduces the volume of the waste. And after heating, it will be transferred to a mixer facility where the waste will be further integrated and becomes a composite material that has the material properties of plastic, but also the durability of other strong materials. So with the different objectives of the industries around Gambia, the composite material will likely be pelletized for storage and later used to form different products as needed. However, in this project, we're going to assume that bricks are going to be the main outcome of this process. So the third stage, or the third section of this process, would naturally be the handling of the organic waste. So after different considerations, social and also financial, we decided to compost the organic waste. So firstly, the collection of the organic waste would occur at the client level, the residences in the community, in the KMC. So the inorganic and organic waste will be required to be separated by the residences into bins, where the collection vehicles would transport each individual bins into our collection site in the ward. So after collecting the organic waste, they will be handled in the ward at our collection sites for composting. So bins of around 5 ton capacity would be filled with organic matter, which requires a mixture of 30 to 1 carbon to nitrogen composition, turned and tumbled every day to distribute and maintain the heat within the composter. This will be done by employees that we hire within the community, and this process will take at most 21 days, which is very efficient given the available options. So as seen, the benefits of the proposed site would be employment creation as we hire employees, but it also reduces the waste volume as most of the waste would be transformed into useful materials like bricks, construction material, and also fertilizers for the majority of the workforce in Gambia as farmers.
Now, the transportation of waste. The transportation system is comprised of small and large trucks. The small trucks will collect the waste from collection sites within the communities. Then, these trucks will next drive to a centralized location of larger dump trucks that will transport the waste to the dump site. These decisions were made as the small trucks are capable of reaching harder to reach locations within the communities than a large dump truck. Additionally, the large trucks are able to drive over uneven surfaces and over longer distances to the dump site. And according to the UN Habitat, this system is actually very affordable. All right, so in terms of cost of the site, we created a table and outlined the different costs. So in orange, this kind of goes over the first stage. This is going to be the temporary landfill, the leachate collection and gas collection systems, while this half of the table goes over the transportation network costs, the brick wall costs, and the transformation and composting facility costs. And our solution comes out to approximately $2.4 million.
Our main objective of this whole project would be to generate revenue that can sustain this whole facility. And with our optimistic estimates, as detailed in the report, we reveal a yearly revenue of nearly $6 million US. And this will not only recover the costs invested, but it will also generate economy and also generate cash inflow into society.
In terms of employment opportunities, we need drivers to drive both the small and large trucks. We need sorters to go through the waste and to extract recyclables and valuable goods, while we also need compost workers to work on the third stage of transformation. Additionally, we need security crew to overlook the facility, and we also need facility workers, HR, and management to manage projects and to maintain structure within the facility. Our site will create over 130 jobs. It will bring over $900,000 in wages per year, and will also create opportunities to grow. Before we designed the site, there were three main considerations that we considered. First, we considered a basic landfill in the new site. While this solution seems reasonable, the predicted waste growth will not fit within the limited space. Next, we considered an incineration facility. While this is beneficial to minimize the volume of waste, it emits toxic emissions and has an ash-like byproduct. Next, we considered a plasma gasification facility. While this not only minimizes the waste volume, it also has two valuable byproducts of slag and syngas. While this was a great idea at first, upon further research, we found that it was way too expensive, and the costs to repair and manufacture the facility were also very expensive.
And now for some concluding thoughts on our proposed solution. For the closure of the old site, we will have achieved successful closure using a quick solution that minimizes harm, and there will be continued monitoring and redevelopment of the area. For the opening of the new site, an entire new system of waste collection will have been created, as well as a lot of new jobs, and we'll be employing innovative technologies that will last for decades. For the societal impacts, the new site will be away from the orphanage, the source of child labor that we mentioned earlier. Better paying jobs will have been created, and waste pickers will be destigmatized. And with that, that concludes our presentation. Thank you everyone for listening, and we will now take questions.
All right, well, I can go first. First, I really want to thank you for this awesome presentation. But before I dive into my questions, I think there was one error in your yearly revenue. There was an extra zero there that might need to be corrected. But one thing that really stands out in your presentation is the lean model. It seems to be very practical. The numbers are very, very lean. I'm not too sure compared to the other ones. It seems to be sometimes an order of magnitude lower. Would like to get a little bit more explanation on that. You mentioned the fact that it's economically not feasible to the situation with Bacote, not economically feasible to really do much besides capping it. And you talked about the different kinds of capping. My question there is about the horizontal gas migration and leachate migration over time. Now you talked about grading it and making sure there's no further water, surface water getting into the system. But what are your thoughts about the horizontal gas and leachate migration? You also mentioned monitoring it with wells and checking the air. But I'm still a little concerned if there might be long-term impacts without doing much further to at least surround the perimeter. I would like to get a little bit more explanations on that. But otherwise, I think your presentation is outstanding. Really appreciate what you guys have done, and congratulate you for that as well.
Yeah, thank you for your comments. So for the gas migration, one of the ways to mitigate that is to combust it at the well. So we have proposed to have utility flares at the top of each extraction well. So that will hopefully combust the gas and prevent it from migrating. And we propose ambient air monitoring around the perimeter of the community. So with this monitoring, we'll be able to see if it's impacting the community, and if it is, even with the combustion of the gas, we can implement additional measures to help. For the groundwater pollution, there's also going to be groundwater wells throughout the site and around the perimeter that will hopefully help see if the leachate generation is significant enough to affect the groundwater pollution. We're hoping that the cover will help minimize any potential leachate generation by limiting the amount of water that gets into the system. Overall, like some of the initial readings that we did, notice that the Bacote dump site didn't generate too much leachate. So going off of that assumption, we're hoping that a leachate collection system is not necessary, because in order to implement one, we would need to excavate a lot of waste from the well in order to install pipes. And for a large site such as the Bacote dump site, it was not feasible to excavate all of that waste and install pipes into it, horizontal pipes, that is.
Thank you for answering that. I would let others.
Thank you very much, 4W consultant, for the brilliant job that you have done. Just to, you made mention of some of the recommendations that you put forward. One is at the new site, you will have some compostings, and then there should be a collection mechanisms where the residents of the municipalities will be doing some sortings. But the number in terms of fleet of vehicle is too small, in the sense that you're looking at 19 wards and more than 500 residents. And then there is no public education and awareness looking into the current behavior or the attitude of some of the residents of the municipality. I think that is very much critical. I didn't see that coming, and then it's not even costed. And two, you made the closure in the budget. There is no cost attached to some of the heavy equipment that will be used during the closing of the facility. So that is like, you said compactor zero, and you made mention of the quantity. These equipments are definitely, or definitely needed when you have to do the closure of the Bacote dump site, because you have to compact all the waste, and then you have to be excavated certain ways and then do some movement. So they are very much required. That whether the cost of about $3 million is will be able to do that closure at the Bacote dump site.
Yes, for the cost estimate for the closure and the vehicles, we noticed that the Conifing Municipal Council already has in their possession a handful of heavy-duty equipment vehicles that we were hoping that we could use for the closure. So then the cost could be minimized in that way instead of purchasing or renting newer vehicles.
And how are the public education and awareness?
Yeah, with regards to composting, thank you for your comment. With regards to the residences, I feel like there will be incentives for the residentials to sort of sort the waste themselves, like possibly because the waste will be converted into fertilizers, which will help farmers within the regions, which make up most of the population. And not only will that be a motivation that in return will give you fertilizers, but furthermore, the residences who are not farmers or who don't work in the agricultural sector, they get monetary compensation. And as you can see, the revenue we generate we will be able to set aside some cash for the incentives. Yes. Does that answer your question?
Right, thanks. I don't know whether this is very much in relation to the question of Kaba, but going by the main report, you made mention of gas collection system. The first one you said utility flare, that is burning landfill, and two is converting the landfill gas to renewable energy. So on page 7, the first sentence, you indicated that the treatment of land gas is not physically nor economically feasible, right? And then you, in the text, it seems you didn't recommend what sort of a system that you will use.
Yes, so I should have reworded that, but I was talking about the treatment or the conversion of landfill gas into renewable energy would not be feasible, because that would require horizontal installation of pipes for collection, whereas the utility flares is more economically feasible because it can just be attached to the extraction wells.
All right, thank you for the clarification.
Yep, just wanted to add a little on that. I'm glad Lamin pointed that out. So when Chris and I were there, we were hoping that there was some kind of feasibility to capture that gas, to use it somehow. For one reason, because the country uses a lot of wood for cooking, and we are thinking of an alternative way of trying to capture that gas, at the very least to use it for cooking. As you know, in most of America, we use natural gas, which is very similar to that methane. But we were looking at that as an option to try to use it instead of just flaring it. Yeah, according to your finding, because the cost that it will take to really capture that, considering the fact that it's not lined, it's just a dump site, might outweigh the benefits. And wanted to know, was that an assumption that you guys made, or was it something that you really digged into to come to that conclusion? Because that could be very critical and helpful to us as well.
Yes. So we believe that when we researched it, for the collection to be effective, we would need to install considerable amount of horizontal pipes. And if that is the route that we want to go, it could be possible. It just would require a lot more funding, because you would need to excavate waste to install the horizontal pipes in order to capture a sufficient amount of gas to be used for like energy or oil or cooking. Or although for like cooking, I'm not sure how much gas would be needed to be collected in order for it to be sufficient. But the combustion seemed like a reasonable and still effective way to mitigate the environmental impacts. But if the cooking is the use for cooking is desirable, then that avenue could be further pursued. It's just for the benefits of combustion or like renewable energy, we weighed the feasibility and ease of closure to be more important than the collection.
Yeah, and if I can just weigh in on that a bit, I think based on the scope of what we have and the information we have here, I think that's a good assumption. I think if we have more resources and time to do a further study, it becomes more of a feasibility study, an economic feasibility study, because installing the horizontal pipes could easily be done as long as there's enough financial return on that, and especially with your evapotranspiration cap, you have a really thick depth of soil there, so you could bury pipes within that without even potentially disturbing waste very much. And then gas tends to rise, so it would come to the top and follow those pipes. So I really liked your evapotranspiration cap. I like that because it can minimize the amount of stormwater that needs to be managed on site. There were some concerns Lyman brought up about that with some earlier presentations. I liked your idea about distributing MRFs or transfer stations throughout the region, kind of that spider network to bring back to a central hub. I think there's some really good thoughts in there. I do have some questions about the patented technology you're proposing to use to treat the waste. I guess a couple things. Is this proven technology? The $1 million cost seems a little low on capital. And then you're talking about heating the waste. Where is the fuel for that heat source coming from?
Yeah, thanks for the question. With regards to the patent, it's from UBQ Materials, which is a Israeli-based company and a startup. They have distributed their sort of products to US companies, but I think their equipments are still quite in the making. So I think in the next few years, when it matures, it will be quite possible to be large-scale manufactured for this use. And they are a B Corporation or registered B Corporation, so I don't expect the cost to be too high, as it is not it's a non-profit company, so it should be more reasonably costed. I wasn't too sure about the costing. Our estimates are quite lean. I think any underestimation is one of our flaws in our calculations. But yeah, and in addition to for heating, I think we will be using, I guess, gas or transportable fuel for that. I don't think we are able to, I mean, we're gonna build piping for the, heating and fuel. We did not really consider that part. That is one thing we left out, but we would build piping for the fuel transfer into that facility. Yeah.
All right, thank you very much. That concludes our Q&A session.